In this question, we have a Lewis diagram drawn for us to represent O3. And we're going to be calculating the formal charge on each of the atoms in this Lewis structure. So formal charge is a accounting method that we use in chemistry. So it just means it's something that we calculate to help us figure things out. And we can find the equation for formal charge on the reference sheet. Here's our equation for formal charge. Formal charge equals the number of valence electrons minus the number of non-bonding electrons minus the number of bonds. So let's write that down. So formal charge equals the number of valence electrons that an atom has minus the number of non-bonding electrons on that atom at that time minus the number of bonds that atom is making. Okay, so let's start by looking at this first oxygen atom 1. Okay, so the first thing we need to know is the number of valence electrons on a free atom. That just means, according to the periodic table, how many valence electrons does our individual oxygen atom have? So let's go to our periodic table and find oxygen. Here it is. So we can see oxygen is in group 16. So according to our shortcut, oxygen is going to have 6 valence electrons. So the number of valence electrons on a free atom would be 6. So that's the first step in our calculation found. Next, we need to find the number of non-bonding valence electrons on that atom in this molecule. So the non-bonding electrons, those are electrons that are in our lone pairs. So we've got 1, 2, 3, 4 non-bonding electrons on our oxygen atom. So that's the number of non-bonding electrons, 4. So we can fill that out. And we can add that as the next step in our calculation. We're subtracting the number of non-bonding electrons. Finally, we're going to subtract the number of bonds. So looking at our diagram here, we have 2 bonds, 2 covalent bonds on this oxygen atom. So we have 2 covalent bonds. So we're going to subtract the number of bonds, and that gets us our formal charge. So here we're doing 6 minus 4 minus 2, which in this case gets us 0. So for that first oxygen atom, our formal charge is 0. Okay, now let's look at our next oxygen atom. So oxygen atom 2. First we need the valence electrons on the free atom. Now this is going to be the same for oxygen, since it's just to do with the number of valence electrons that atom has according to the periodic table. So it's just going to be 6 again. And we can fill that in our table. Next, the number of non-bonding valence electrons. We have 2 electrons that are not involved in bonding. So we've got 2 non-bonding electrons in our valence shell. And lastly, the number of bonds. We've got 2 covalent bonds from this double bond here, and 1 more covalent bond from the single bond there. So we've got 3 covalent bonds in total. So 3 bonds. Okay, so now to calculate our formal charge, we're doing 6 minus 2 minus 3, which gives us 1. So our formal charge on this oxygen atom is going to be 1, or positive 1. But we don't write a positive number for positive numbers when we write them in our boxes and our answer box. We only need a negative sign if we have a negative number. Okay, so finally looking at our last oxygen atom, number 3. The number of valence electrons on a free atom, again, that's going to be 6, because that's just the number of valence electrons according to the periodic table. Next, we want the number of non-bonding valence electrons. So we've got 1, 2, 3, 4, 5, 6 non-bonding valence electrons. Okay, so we've got 6 of those. And the number of bonds we just have one covalent bond here. So we've got one covalent bond. And for our formal charge calculation, we're doing the number of valence, which was 6, minus the number of non-bonding valence, which was 6, minus the number of bonds, which was 1. So 6 minus 1 gets us minus 1, or negative 1. So our answer is negative 1 for the formal charge on that last oxygen there. So that's our technique for calculating formal charge. We look at each atom individually. We use the periodic table to find the number of valence electrons that would be on a free atom of that element. Then we look at that atom in our molecule and we look at how many non-bonding valence electrons we have and how many bonds, and then we put them into our equation for formal charge, which is the number of free valence electrons minus the number of non-bonding valence electrons in that molecule minus the number of bonds on that atom in that molecule. That gets us our formal charge. In the next skill, you'll find out more about what formal charge means and why we calculate it.